nowhere.
Oh, so we won't have to come in anymore, so I won't have to talk to anybody or something like that?
That will be possible.
Do you have a mic or something?
So, Alex, you have the floor. Please.
Great. Well, thank you very much for having me. I'm happy to be here today sharing some of my experience from the field of behavioral economics with you. And I'm going to talk about modeling individual preferences. I'm flexible about how we do this, so feel free to stop at any time and we can chat. I might draw a few pictures on the board, we'll talk examples. We can do this whichever way works best for you. But I'll try to get through a few key things. So a little bit of motivation before we get into some different kinds of preferences. A bit of motivation on why we should care about preferences. And I'll give you two takes on this. The first one at the micro level. If we're thinking about individuals, we should care about preferences if we want to do a better job of understanding and predicting individual choices, like the decisions that consumers make. So take buying a car, for example. The decision is often governed by budgets and prices, but preferences matter too. So like Stephen Levitt, the author of Freakonomics, he still drives a Toyota. He's just not interested in spending a lot of money on a car. That says something about his preferences. So there's a micro level example about why preferences might matter, and we should care if we want to understand behavior. But I also want to say something about the macro level, and this comment here is a little bit facetious, but I'll just read what I wrote anyway. On a macro level, because the best macro models are based on proper micro foundations.
That could be almost from system dynamics.
Okay.
Forrester is saying macro behavior comes from microstructure.
Perfect. So we're on the same page. I mean, I wrote
That's
that.
what the materials people say.
I wrote that paying homage to Robert Lucas, who won the Nobel Prize. In the 70s, some of those highly aggregated macro models really weren't doing a very good job of predicting what was going on in the economy. And so Robert Lucas was one of the people who said, look, if we want to do a good job of predicting on an aggregate level, we really should think about what individuals are doing. Let's do a good job of modeling the individual decisions and then aggregate up from there. Now, there are different ways to do macroeconomics, but that's one view. And if you're going to pursue that, then you need to know something about preferences. So I'm going to talk about some different kinds of preferences today. Try to touch on three different types. Time preferences, first of all. People's preferences for consuming today versus delaying consumption to some point in the future. We'll talk about that. We'll talk a little bit about risk preferences. So in an uncertain world, how do people make decisions in the face of risk? And finally, I'm going to touch on one of my favorite social preferences. So if we relax the traditional assumption that people are purely self-interested and care only about their own payoffs, if we allow them to consume, to care somewhat about others, then what kinds of decisions do they make and how can we model such preferences? So that's my goal, is to at least touch on all three of these, and we'll see how well we can do. All right, so let's start with a little bit of background on utility functions, because I'm actually going to use utility functions to capture all of these preferences that we're going to talk about. And I could give a whole lecture on utility functions, but I'm going to try to give you some of the key points in 5 minutes or so. We'll start with a little bit of a history lesson, and I use that term loosely. Way back in the beginning, it was thought that maybe well-being or happiness or utility can just be captured by what you can consume. So like your happiness is equal to the number of slices of pizza that you have, or the number of donuts that you eat. But think about what this implies for a moment. What it means is that your fourth slice of pizza is just as satisfying as the first one, right? Because utility is just increasing at the same rate as your consumption. You might not be okay with that implication, right? Maybe you think it's the case. Or keep going, make it the 20th. Maybe we're talking about bottles of beer. I mean, We can come up with examples where this assumption is just not appropriate, right? How do we fix this problem? Well, maybe utility should be some kind of a function of consumption. For example, if utility is the square root of x, where x is your number of slices of pizza, then you get the property that that first slice gives you a lot of additional happiness, and the extra slices give you additional happiness, but less and less. So on the margin, you're benefiting less and less as your consumption increases. You've got diminishing marginal utility. That's a pretty appealing property for a lot of consumption goods. That's one of the reasons we use utility functions, so that we can capture the kind of properties that we might want to have based on our observations of how people behave in the real world. Okay, so a little bit about utility functions. Right, so that utility function only had one good. In the real world is a little more complicated than that. There are lots of goods. That's okay. We can incorporate more goods into our utility function. For example, if our two goods are X and Y, coffee and donuts, we can write coffee and donuts into our utility function and maybe make utility the square root of X times Y. That specific form is called the Cobb-Douglas utility function, and it has the property that the marginal benefit you get from each extra unit of a good depends on how much of the other good you're consuming. Maybe you want that, maybe you don't. But in the case of like coffee and donuts, this kind of utility function would imply that the more coffee you drink, the more happiness you get from being able to have a donut as well. Because, you've had too much caffeine and you're really hungry now. So you might want some kind of relationship between the quantity of one good and the happiness you get from consuming the other. The Cobb-Douglas utility function gives you that. Now, another way of specifying utility is using an additively separable function. So you don't have that property that the benefit you get from one good depends on how much of the other one that you're consuming. It's not the most realistic assumption, but it can be a convenient modeling choice because now you've separated the two goods out in your function. Okay, so right, that's a little bit about utility functions. Now I'm going to get into how to model time preferences, starting with a traditional model of time preferences. We'll talk about that for a little bit, and then we'll sort of test out some of the implications of the model and see if we can do a better job in light of some common choice behavior. So the typical approach to modeling time preferences is to use what's called the discounted utility model. Benefits in future periods get discounted using the discount factor beta, which is something larger than 0 but smaller than 1, so that the future consumption isn't as valuable to you as current consumption. So like if we've got time periods 1, 2, and 3, and utility in a given period is the square root of consumption, then we could write utility is equal to the square root of what you consume in period 1 plus beta times the square root of what you consume in period 2, and we just add a beta for each additional period. So the number of periods into the future, you discount that number of times. That's the traditional model, and it gives us that people have a preference for consuming things now instead of later. I'd rather have that donut right now than tomorrow. That's something we get from the discounted utility model.
So
This is a
how
workhorse.
does retirement savings, Social Security,
Well,
does that justify?
there's a trade-off there. So basically, if I've got 100 in lifetime earnings, the way to maximize my lifetime utility function, the big U, is to spread my income out over the periods 1, 2, and 3. Because if I consume it all in one, then When I consume that last unit, my benefit is really low, and I could increase my overall lifetime benefit by spreading it out, putting some of it in the later periods, where at a consumption level of 0, my benefit of the first unit is really high, right? Because of the way we specified that function. Yep.
Is this a really general model? Because some people prefer to have things later than now.
So they would have a higher beta.
Okay.
So it is fairly general. It's not perfect. I'm going to start poking holes in it on the next slide.
Okay.
But the way that I would incorporate different kinds of preferences in terms of how impatient people are is to change that beta.
Well, yeah, but what she was talking about is a beta that's larger than
So,
one where you prefer to have something in a day or two, right?
Yeah.
So if you include so this is kind of on, it's, I assume,
Mhm.
based on a monetary discount
Yeah.
model. But if you think about preferences, having things, and then you include intangibles like anticipation and all that,
Mhm.
you might actually end up with a beta that's larger than one.
yeah, fair enough. I think you could add another parameter for some kind of anticipation effect, or you could have the beta larger than 1. That's absolutely true. This is the standard model. Those are 2 ways that we could adjust this to get those properties that you want. Now I'm presenting this as the traditional way of doing things, and I've got some big issues with this too. The issues you've pointed out so far are the same as mine, but at the end of the day, we could really pile on and knock this apart. This is the most common way of doing things. So I think that's the point that I would like to make at this stage.
Maybe
Okay,
when you're an academic, you're just so trained to think differently.
a lot of people just take this as given. Yeah, I don't, because I'm a behavioral economist. I run experiments, and I come up with better models. Okay, so let's do a hypothetical here. I wish I could do this with real money, but I left my cash in my office. So let's consider a couple of decisions. Decision 1, think about what you would do, okay? We'll do this just for fun. Don't look at decision 2 yet. I should have put it on a different slide. Okay, only up top on decision 1. Option A, $100 right now. Option B, $105 tomorrow. What do we have? We got 6 people in the room. Maybe we'll take a vote. Who would choose option A for decision 1? Who would want the $100 right now? You're on 1, yeah?
Yeah, me too.
You want it right now?
I'm not sure I would come tomorrow.
These
I
are
won't.
grad students, they're cash strapped.
No, okay, so we got 2. Let me do it the other way around. What about B? Who would wait? Wow. Okay, so let me tell you what typically happens with a large group of undergraduate students, and we can debate the extent to which they're representative, but that's a little bit of a side point. What typically happens, people would really like to have the $100 right now. So a lot of people choose A. The majority of people choose A in most audiences. Okay, so for decision 1, most people choose A. Let's look at decision 2. Forget about decision 1, okay? Decision 1's never happened. Decision 2, option A is $100 on January 29th. That's 3 months from now. And option B is $105 on January 30th. What do you think most people choose in this case?
B.
Yeah, if they have to wait 3 months anyway,
3 months.
then they're okay with waiting the extra day for the $5. That's a very common finding. But the majority go for A on decision 1. The majority go for B on decision 2. And the thing is that they're not really different. So the only thing that's different is when you make the choice.
Mhm.
But you're getting $5 of compensation for waiting a day. The discounted utility model can't cope with that, right? The discounted utility model would never predict different choices for these 2 decisions. Okay? So that's a problem for the discounted utility model. It's just not going to deal with that kind of choice data. Here's a model that does. It's called hyperbolic discounting. maybe beta depends on how long you have to wait, right? So maybe that beta that we use to do the discounting isn't the same if we're talking about today versus tomorrow, Friday versus Saturday, January 29th versus January 30th. Maybe the time to the realization of the benefits affects the beta. You know, again, that's something we can discuss, but that's the main idea behind the discounted utility model. And I actually just want to draw you a picture because I didn't put diagrams on the slides. But what this implies for beta, and I'll try to keep all the pictures pretty close together, is that if you have to wait longer, your beta changes, it's rising. So that's not really hyperbolic. I want to show you the translation that gives us the title hyperbolic discounting. So beta is the discount factor, right? And it implies that something we call the discount rate, rho, is hyperbolic, okay? That's where the title hyperbolic discounting comes from. The discount rate is hyperbolic in a hyperbolic discounting model. What this model gives us, though, is a way of rationalizing. No problem, come on in. It gives us a way of rationalizing those decisions that are common in those two decision scenarios from the last slide. With a hyperbolic discounting model, choices are consistent, you know, with the predictions of the model, which is kind of neat. So it's this kind of model that solves that problem. So the thing is that in the future, you know, you discount benefits a lot. So in the near future, I should say, and benefits in the distant future, not quite as much. So you're willing to wait the extra day to get the extra $5. There's a way just of writing the utility function if we've got that beta that varies depending on how long you have to wait until you get to realize the benefits. So I don't want to get dragged down in the math of it, but I do want to point out that this gives us what's called an immediacy effect. And the immediacy effect is that if I'm making a choice between right now and a little bit later, I discount a lot. So the little bit later hurts a lot. But if I'm making a choice between 2 points later in time, the discounting doesn't hurt so much. You know, that's the immediacy effect that gets captured by the hyperbolic discounting model. And the discounting utility model, the traditional approach, is never going to give us that. So this is a nice way to reconcile the kind of choice data that we talked about on the last slide. Kind of complicated though, because the beta is a function of t, which maybe we don't want. So I am going to give you a simpler alternative that's kind of in between the two models that we've talked about, and it's called quasi-hyperbolic discounting. A guy named David Lapsam at Harvard is one of the big pushers of this model. He's one of the main people behind it. With quasi-hyperbolic discounting, you get the immediacy effect, which we need to rationalize that choice data we just talked about. But you don't have to have this complicated beta as a function of t thing. You just have to incorporate one additional parameter. And that's why I actually think the quasi-hyperbolic discounting model is a really nice way to capture a wide variety of behavior. You just add this delta parameter to any period that's in the future. So this utility function is basically the discounted utility model, except if the period is anything other than now, if it's anything in the future, we also discount it by delta. And now we've got the immediacy effect. Yep.
So does that mean that the difference in 3 months is going to be the same as the difference in a year?
Yes. Yes.
Is that the case?
Because they'd both be empirically, if you're willing to wait a day 3 months from now, you're highly likely to be willing to wait a day a year from now.
Okay.
So that does match the data very well. Yeah. You know, there are always exceptions to the rule. We're talking about averages here when it comes to going out in the field and dealing with real people. But it matches the data pretty well.
And both delta and beta are less from 0 to 1?
In the traditional model. Now, we might have these anticipation effects, then we might need to go outside of that range. The typical way of thinking about this is to have both of them between 0 and 1. So you always have a preference for right now instead of later.
I have a question about these two diagrams.
Yep.
So is this on the right is a derivative of this, or the rate of change of this?
It's
of the
it's
beta?
the inverse.
The
It's
inverse.
one over.
Oh,
It's
one
the
over.
inverse. Yeah. Yeah. Good question. Okay, so this is a very well-liked model in behavioral economics because it does a good job with a wide variety of choice data. And that's a contrast to the discounted utility model because of the addition of the delta. Gives us the immediacy effect. That's something we like. That's a little bit about time preferences. Okay, I'm gonna hop to risk preferences and talk a little bit about that. At the end, we can kind of discuss more generally. Risk preferences though. So how do we incorporate how people feel about risk? Well, one way to do that is using the shape of the utility function. So like if the utility function is concave, people don't like risk. If it's the opposite, if it's convex, then people are risk loving. Let me just try to draw you a picture of this and explain how it works. So people's payoff is X, and they have the utility U. And if they've got a concave utility function, like utility is the square root of X, it looks something like, if we can get it on the board there, like that. So in a world where there's uncertainty, you know, maybe you get a really low payoff, like 0, or maybe you get a really high payoff, like, I don't know, the high value of X. So this is 0. That's the high value of X. If people take a gamble, you know, the way we think about the happiness they get from that gamble, some chance at the low payoff of nothing, some chance at the high payoff, XH. The way we think about that is to say their happiness is going to be given by the expected utility that they get. So if they get the low outcome, their utility's down here. If they get the high outcome, their utility's all the way up here. In expectation, you know, they get that intermediate level of utility. So their expected payoff is in here somewhere, and their happiness is kind of given by the convex combination of those two outcomes.
A very mechanical question.
Yeah.
Which one is independent variable, U or X in your
The X is independent, so that's you know, whether I win or lose my coin toss. Stock market lost me a lot of money. Stock market made me a lot of money.
You have in addition here a probability of getting this, right?
Yeah, I put it in the middle so that this is.
So
a
did you just assume a uniform probability?
Yeah, so I'm just drawing a picture where there are two outcomes. We'll say they're equally likely, just for simplicity. The specific probabilities is not really what it's about.
Okay.
It's
No,
more
just
about
in
the
order to
fact that
understand what we have.
if they gamble, you know, the expected happiness is something like this. Check out what would happen if the person didn't gamble. If they just got the expected outcome, their utility would be up here. So the fact that getting the expected outcome with certainty is better than taking the gamble, that's the person who doesn't want to gamble. That's the person who's risk averse. So the utility from getting the expected outcome is higher than the expected utility that they get if they have to gamble. They would rather just take the certain amount than have to gamble. You know, that's captured by this difference between the two. That means there's a market for insurance. They pay this amount of money to sell that risk to someone else. So the concave utility function gives us risk aversion, creates a market for insurance, where someone's willing to pay the difference between their expected utility and the utility of the expected outcome. They're willing to pay up to that much in order to avoid taking risk. That's the traditional way of thinking about risk aversion and utility when there's uncertainty. So that's the traditional way. Let's do another little choice experiment. See if our choices are consistent. Well, I don't want to lead you too much. Let's think about decision 1 for a moment. Pretend decision 2 is not there. Option A is $200, no uncertainty. I give you $200. Option B involves some uncertainty. $600 with a probability of 33%, 0 with a probability of 67%. Would you prefer option A or option B?
A.
You prefer A? Yeah. A is the common answer.
Yeah, I'll take A.
Decision 1, most people go with A. You know, they'd rather the certain amount. So that's having a preference for the certain amount instead of taking the lottery there. You know, A corresponds to the top one, utility of the expected outcome. B corresponds to taking the gamble, the expected utility. Okay, so people tend to prefer A in decision 1. What about in decision 2? Let me change things up on you a little. Option A is that you lose $400. Option B is that you lose nothing 33% of the time. You lose 600, 67% of the time. What seems more appealing there?
B.
Option B.
Perfect. That's exactly what people tend to do. Not all the time, but on average, that's what happens. Expected utility doesn't give us that. Expected utility says that you choose the same thing each time. All right? So expected utility is missing something.
You have
So
to
what's
know.
happening now?
You
Decision 2.
prefer
You prefer to win things, but if you're gonna lose it, you'd rather have a chance at not losing.
Yeah.
The winning and losing, I think, is a very nice way to put it. I'm going to go to the next slide because it's got the answer. Daniel Kahneman and Amos Tversky, 1979, prospect theory. People treat losses and gains differently. Now, our traditional expected utility model doesn't say anything about that fact. Kahneman and Tversky said, look, you know, if people are looking at benefits, they think about them very differently from gains. Sorry, losses. Losses and gains are treated differently. Benefits and costs are treated differently. How can we model that? Well, that utility function I've written up there in that last bullet is a very simple, straightforward way of capturing the key insight in prospect theory. I'm going to have to go over to the board once more.
Yeah.
I'll draw a picture of that. Some of you can probably already figure out what it looks like and sort of have a sense for what gives us the key difference from the traditional model. With prospect theory, we're going to talk about gains and losses. And in the gains, there's really nothing different from the traditional model. You know, if the person's making money, if they're in gain space, utility is the square root of x. So it's concave like before. But with prospect theory, we're also thinking about what happens if the person loses money. And it's bad news. You know, minus 2 the square root of the absolute value of x, just so that, you know, x is negative, make it positive so you can take the square root. That's what the utility function looks like with prospect theory. We've already talked about how with a concave utility function, the person doesn't want to take risk. In decision 1, you guys chose A. You didn't want to take any risk. In decision 2, we were talking about losses. You guys were willing to take risk, implying that you have a convex utility function, and that's what prospect theory has, right? You are willing to take gambles so that you don't have to lose money, right? So it kind of flips what we had on the board with expected utility. This kind of utility function explains the choice behavior from the previous slide there, the decision 1 and decision 2. So it's a pretty nice model. I mean, it does a better job than the traditional one. I don't know, I kind of like the losses versus gains thing. There's one thing with this model that's like really hard to define or kind of figure out or implement in the real world. Does anyone have a sense for what that might be?
Is this continuous? The model actually changes?
Yeah, this here.
That customer right there, right? The origin. We got a name for that guy. Or that lady. She's called the reference point. Where does that reference point come from? Because if we don't know where that reference point sits in the real world, then we can't really apply this model to real world situations. Is it really 0? Is my reference point having a wealth of 0? Or is it something different? Is it the wealth that I woke up with this morning? Because I need to know where my reference point is in order to apply that model. And so like the $1 million question with prospect theory is, where does the reference point come from? What defines your reference point or your reference point? Because if I don't know that, I can't use this model to predict your behavior.
So why is it not just a status quo?
Well, that's one explanation for where the reference point comes from. So there are 4 common explanations for where the reference point comes from. And the truth is that which one is the best fit tends to depend on the particular decision-making environment. Status quo is one of them. Expectations is another one. So if I expect the stock market to go up by 7% and it goes up by 10%, I'm happy. If I expect it to go up by 7% and it goes up by 3%, I've made money, but I'm not happy because I think I should have done better. So that's expectations. 2 more. Maybe I judge my reference point based on my peers. My MA classmate, who's been working at JP Morgan for the last 10 years, has made X since we were classmates. X is a pretty big number, in spite of the financial crisis. That could determine my reference point. It actually doesn't for me, but I can tell you that when my investment banking friends think about whether or not they're happy with their incomes, they compare. They compare amongst themselves. So the peers can be the source of the reference point. What's the other one? The 4th one is goals. Goals might be the source of the reference point. Maybe you have a goal of doing 50 push-ups tonight, or losing 10 pounds next month, next year, whatever it might be. If you fall short of your goal, that probably puts you in loss space. If you exceed your goal, you're probably pretty happy about it. I don't know what the right answer is for the reference point. Yep.
Changes over time.
Yeah.
Since you mentioned of a friend who works at JP Morgan.
Yeah.
I had a real class fellow.
Yeah.
Who worked with me. He did his master's at Sloan School, and and the others sort of chugged along in our PhD program. We finished in 2 years, and this was in 1970 something. Got a job with a starting salary of 80,000 in 1970. The university professors, MIT assistant professors made $15,000. So that was a big deal. And a few years later, I heard that John Lamb is now making 250. And a few years later, I met one of my friends and he said, "You know what happened to John Lamb?" I said, "No, I was making a lot of money." And he said he killed himself. So, so here is over time, there is this change coming. Is that captured in?
It's not. That's a snapshot. That's a static model. And I think the truth is, we don't know where the reference point's coming from, and it's moving around over time.
Yes, the
Right.
reference point is changing.
So it is.
Yeah.
And maybe we can construct a theory about how it's changing. Kahneman and Tversky don't do that. You know, that's what they gave us. So yeah, that needs a couple of additions in order to incorporate what you just mentioned. The fact that time is a factor too, that's moving around. It's not part of the model as is. So that would be an extra component. But that's not a bad start to thinking about the fact that people treat losses and gains differently. Expected utility doesn't account for that at all. So I think that's a step in the right direction. Okay, so that's a little taste of risk preferences. I got one more kind of preferences to tell you about, one of my faves. Oh no, I shouldn't tell you. I shouldn't tell you we're talking about this kind of preferences yet, because we're gonna start with a choice experiment first. Yeah, I didn't bring cash again. Yeah, well, it hasn't changed in the last 10 minutes. So we can't do this with real money, but pretend it's real money. And Colin Kammerer, he's at Caltech. He published a book in 2003, Behavioral Game Theory. He reports oodles of these results across lots of different studies. So like cross-cultural, all that stuff. Good reference. But think about this game called the dictator game. There's a pair of people. One of them is the dictator, the other is the recipient. The way the game works is that the dictator decides how to divide $10 between him or herself and the recipient. Okay, that's the game. The dictator makes a decision. What do you think people do?
A lot of people just want the $10.
A lot of people do. Most of them don't keep the $10. In a room full of economists, system dynamicists, etc., that could be hard to believe. But
No,
it's true.
actually,
Are they anonymous?
Anonymity matters, but the fact that most people don't keep the money is robust to whether or not they're anonymous.
I mean, you would, first of all, there is an expectation you are a dictator, there is some fairness in you.
Yeah,
There's that expectation.
Because you're not real.
What's
And then
fair?
you also have this fear that, you know, if you give the other guy nothing, he or she would rebel. So there is a fear factor too. So you'd give something.
we can take that out of it. So we can construct a design such that there's no potential for retaliation, right? So like we can have people connected online in different countries. They're never going to see each other because they have no information about each other except that the experimenter has connected them over the internet. They still give money.
How about that
Give
expectation, self-image?
Expect all of that. Those are very real things, right? Now they're not accounted for by the traditional model, that utility function I showed you at the beginning, where I care about my payoff and nothing else. But they absolutely matter in the real world. So when it comes to the real world, the fact that I know the recipient might have an expectation, I don't want to fall short of that expectation, that affects most people. And the degree of anonymity matters as well. You know, if I have any kind of connection to the person, that matters, absent the potential for retaliation. All of these factors matter, and that's missing from the traditional model.
Does it change with the change of the amount?
Yeah. So how does it go? So in the $10 game, a lot of people give 5. Quite a few give 0. The most common amount is actually 5, but the average tends to be 2 or 3, depending on your population. So that's with a baseline of 10, right? 20 to 30% is the average. John List did this in Florida. He's now at Chicago with Stephen Levitt. John List did this at Florida with $100. And students at the University of Florida, the average was still 15 to 20%. They were giving $15 or $20 away. Students. So I think that's pretty telling. So the percentage moves around a little bit, but qualitatively, it's a similar story, even if you raise the stakes. So that tells us that
So
maybe people,
would charity giving fall in that?
absolutely, yeah. So now I'm going to show you just a couple of different modeling approaches that move away from the traditional self-interest model into something a little more general, and they account for charitable giving, volunteering, all of that good stuff that people do for each other. I'd say the start of it was Gary Becker in the 1970s. You know, let's say payoffs X1 and X2 are my payoff and the payoff of someone else. You know, in my utility function, it's not just my payoff x1, but also x2, someone else's payoff, maybe my recipient. I care about them because alpha is bigger than 0. I don't care about them as much as I care about myself. Alpha is less than 1. But now we've
Less than
incorporated.
one, less than one.
Sorry?
Okay, later.
Now we've incorporated some concern for others into the utility function, and you know, this can be used to justify choices such as giving something positive in the dictator game. Gary Becker actually talked about like parents and the extent to which they might care about their children. There, you could totally see alpha going over 1, right? So in the basic model, we think of alpha being between 0 and 1 because, you know, I care about others, but not quite as much as myself. But if you're talking about your kids, maybe alpha's 2 or 3. You know, we can argue about what the number should be. We can observe choice data to try to figure that out. The point is that alpha is not 0. The traditional model says alpha is 0. That doesn't do a great job of predicting why people would give money to charity or volunteer their time for a nonprofit organization. It just doesn't really make sense. We kind of need to have a positive alpha in the utility function to explain something like that. So that's the basic formulation from Gary Becker. I just want to mention a couple of other models of social preferences where people don't just care about themselves, but also others. Inequity aversion, that's Fair and Schmidt, Quarterly Journal of Economics, 1999. Ernst Fair was pretty high up in the gambling odds for the Nobel Prize about 3 or 4 years ago, but you know, it hasn't happened for him yet. Anyway, in this model, and I won't show you the utility function, but you could Google it if you wanted to know. I'll just tell you some of the key parts of the model. With inequity aversion, people care about their own payoffs, but that's not it. If they get more than someone else, they feel guilty about it. And so the idea is that a dictator might be constrained in what they keep for themselves, because if they keep too much, they feel guilty. That creates some disutility, and so they give some of the money away. Guilt creates disutility. Envy creates disutility. So let's say I'm in a bargaining game with someone, and they offer me something, you know, a very low offer. I don't want to see them come out with much more than me, and my envy creates disutility for me, pushes me toward rejecting the offer so I don't get the short end of the stick, I don't get the bad deal, right? Inequity aversion has guilt, it has envy, and the parameters in the model make envy more painful than guilt. That's how the two compare. You can think about how much you like that, but that's how the model works. It's consistent with dictator game results and other sorts of results from like bargaining games and so forth. That's one model. I'll just briefly mention another one. It's reciprocity, Matt Rabin, American Economic Review, 1993. Here you get utility from your payoff, and you also care about how you treat others, especially those who have treated you well or maybe poorly. So basically you care about your payoff, and then you also feel good about returning treatment. So if somebody treats you well, you want to treat them well, that gives you more utility. If somebody treats you poorly, if somebody cuts you off on the highway, now you get happy if you can make their day a little worse by doing whatever you're going to do. And we won't go down that slippery slope. But that's reciprocity, another way of modeling that it's not just your own outcome you care about, but you're affected by the outcome that another person receives. Okay, so that's pretty much what I wanted to talk about, and I used plenty of the time, but I do want to open it up for discussion and Q&A and so forth. I will just try to summarize my main point, and that's that by paying attention to what real people do, I think we can do a somewhat better job. I'll weaken my statement from up there a little bit. I think we can do a little bit better with modeling preferences, and I think this creates some potential to develop better micro and macroeconomic models. That's why I think we should care about this, and this is worthwhile stuff for us to consider. But that's what I wanted to present. So I'm happy to answer questions and have discussion. Do whatever you'd like with the rest of the time.
I couldn't agree more with those statements.
Okay, all right. So thank you for the support. Any Any questions about any of this?
You know.
Yeah.
Go ahead.
No, go.
So this is all framed as an economic problem,
Yeah.
right?
Yeah.
But you could think about it as an educational problem,
Mhm.
right? And in a lot of the same, what are the motivations for people to do whatever and so on? And it would be interesting. I mean, you could potentially use the utility
Mhm.
issue, but it's not as much an economic as kind of the benefit to them, to some other people, to,
Yeah.
and I wonder how much of that is transferable. And I'm not only saying, maybe you can use it for health behavior. I mean, all kinds of other things
Yeah.
that are much broader than the economic sense, I think. And now I'm going out on a huge limb, but I'm saying, living in a positivistic time frame, we tend to go economic because that's something we can measure,
Yeah.
right? How do you measure health?
Yeah, it's a tricky thing. So I just want to say, as far as the modeling, you're absolutely right. X is an amount of money, right? That's the way economists think about it. I think there's a lot of potential to be more general than that. X really could be a health outcome. So, your happiness can be a function of your health outcome. And that's something that I think actually works pretty well in theory. So I think we can go through all these theoretical steps pretty well, just thinking of X as a healthcare outcome. I think the challenge is with moving to the field and thinking about how to measure X in the field. That's where I think it gets
So
challenging.
that particular example, actually, Michael Grossman has done this. His model health is a driver of utility. So
Yeah.
directly,
Yeah.
both directly and indirectly. So
Yeah, but it's postulated, it's not measured. So he talks about stuff that he can actually measure. How do you measure health, right?
Well, there are indicators like quality of life years.
Yeah, but
And there are indexes. out
yeah,
there
but they're
that we
not.
use.
Yeah, the qualities and stuff like that.
Qualities.
But they're not very sensitive. From a practical point of view, how do you do these experiments
They're
that
not
you can do
monetized as dollars, but
well, also they have longer time frames.
Yeah.
Right? But the issue, but maybe, there are ways where you can, especially now with big data, right, where you can mine data to look at an aggregate and get the information from there. Somehow, I don't know. This is very fuzzy, but my thinking is very fuzzy on that. But it seems to me that if you can't get the data along a timeline, which is what you would need,
Mhm.
maybe you can get it out of an aggregate of data points in some hocus way.
Well,
I think
You understand what I mean?
the question Isa is raising is tangentially related to individual utility versus social utility. There
In
are
some sense.
health
but-
and education also have social utility.
Mhm.
And I don't know how that can be measured and how is that determined. We talked about individual utility functions.
Yeah.
It also matters if it's affecting society or not, because there are
Well, that's
certain
what
health
we say.
programs that don't affect society, they just affect individuals. So if you're talking about the individual's health versus society's health, it makes a difference.
In some ways, individual health affects society. If workers in a production in a factory are healthy, they produce more goods and services available. If someone has infectious disease, that affects the society. So
There's more healthcare costs and so. Now, as you have mandatory healthcare or national general healthcare, the connections are much tighter. But that's for health. You can talk about the same thing in terms of education and quality of life, right? If you have educated people, I mean, you would assume they make less stupid decisions as an aggregate. But it
I mean,
seems to me that this can be broadened.
We also have to take into account ignorance and people who choose to be ignorant. Because there's also happiness in that direction as well. So you have to take that into account. If you're talking about intellectual education, like going to college and getting a better job, it's different than just education as a basis of more knowledge and not making stupid decisions. There's different
Yeah,
kinds of
I always
educations.
talk about education in the sense of, not in the sense of getting a better job.
So there's some people who choose to be ignorant and they're happier not knowing than knowing. And so you would have to make a utility to take into account the knowledge that you're receiving. And if it's
So
good or bad.
I think, this is very simple, but there is the potential to expand this. We could have the payoff of every member of society in there, and you apply a different weight to each person's payoff, and that's how I start to care about someone else's healthcare outcome.
Mhm.
Notice that if that other person gets me sick, that's going to affect my own outcome.
Yeah.
So that's going to come right into my own payoff, right? So, I do think that there's a lot of potential here just by putting other people's payoffs into the utility function or healthcare outcomes to capture some of this. And I, don't have the right way of measuring some of these outcomes. It is somewhat hocus pocus.
I think that's
Okay, so
the
the
big
interesting-
problem with the theory. Part of the theory depends on measurements, and those measurements are not. I'm thinking of environmental economics.
Yeah, so I'm not a theorist, so I hate to defend the theorists here, but I actually think it's the empirical folks that have to do a better job of measuring things.
But if I theorize over something and there is a variable or a parameter there which is not possible to measure,
Mhm.
then that theory does not exist,
Well,
which is a problem with the theory.
I'm wondering though, if you can measure, what measures the wrong term, if you can experiment
Mhm.
with something where you don't get numerical outcomes in the sense that we're used to them in this kind of counter rationalism, but you, in the same sense that you can, we say in models, right? This is improved. We don't know how much it is improved, but it's improved, right? So or this decreases it, right? I mean, that's also an outcome. It's a much vaguer
It's also
outcome, but
an
it's
ordinal comparison.
right. But that can, if we would learn how to work with these things, we could probably use some of this stuff until we get better.
Yeah, so I think there are some tasks here for the theorists. I think there are some tasks for the empirical folks. And I think there's a little work that could be done all around. Saeed, you had a question?
Yeah,
Yeah. Has
yeah,
anybody
definitely.
used behavioral economics theory into macro models or bigger or kind
Yeah.
of models or?
They definitely have. And I would say that, my take on the most common application is of the time preference models to the retirement savings decision. So, there's a School of Public Policy at Harvard where they have looked a lot at the retirement savings decision and how can we better understand how people fall into some of the pitfalls. And the behavioral models have been useful for understanding.
And that makes sense that they work on that because there's money there.
It's a big topic.
So what's the term that they use to describe this type of approach when they journalistically encourage people with incentives to act in a way that's good for them? Like when the government steps in and does something that people will.
Yeah, I know what you're talking about. I don't know if
There's a term for it, I think.
Okay, I'm not sure what the term is. I would just say it's paternalistic, but I think you're looking for something different from that. So the best answer I have for you is the retirement savings thing.
So,
And you can see how that works, right? I mean, we talked about the immediacy effect. So basically, because there's always this immediacy effect, I always think that next year is the year to make the big contribution to my 401k, right? So in 2015, I think 2016 is the year where I'm going to make the big contribution. In 2016, I think 2017 is the year where I'm going to make the big contribution. I do the same thing every year. That's an application of the immediacy effect and either one of those behavioral models that we talked about.
I was going to say, I was just thinking about this as I work in the medical device field, and we have to try to assess people's ability to use things and understanding of things. And it's a tough thing to measure because you have to provide them these products and make sure they're not confused. And so, how do you measure confusion or understanding? And so that you go through, try to work simulated scenarios and look at their behaviors and try to score them in ways. We use Likert scales, and those are sort of a lot of subjectivity to that. But you try to get sort of a trend. You look at trends of people's interaction, the way they interpret things. It's kind of interesting. So there's these techniques in human factors engineering that I think may be interesting to look at how human factors people and psychological engineering folks apply their discipline. Because I never quite understood all that. They go in and interact with people and they say, "Yeah, this person was good." I'm like,
this is an interesting point because coming from the quantity side of the world, I personally am always faced with this. Is a 3.8 student really that much really better than a 3.7 student? Right? He is 3.8, but is he really a better student? Right? But we're convinced it is because we're coming from the quantity side. Well, if you put that aside, right, and just look at kind of the way the human factors people have to, right, say, well, they function like this and they function like this, and overall they seem to be functioning well, right? Or overall they seem to be functioning not so well. Without having the 3.7 or 3. I mean, I think you can still say something.
Yeah, it's funny because
it's a weaker statement, but you can still say.
So one of the things that we did, we passed with using these Likert scales. So we got the criteria to pass. We define our criteria for passing, but then our evaluators in the government were very interested in all of the observations and all of the feedback that people. So they honed in on stuff, and they were trying to ask us to really go deeper dives into the stuff that was more the interpretive stuff that the users of our product were dealing with.
Yeah. So it's a very basic question. So with these different kind of models, how people pick and choose which model to use, because everyone has different features and different things to consider.
Yeah, that's a bit of a controversial thing, right? The economists in general, but then also the behavioral economists are often accused of just picking what's convenient for them, works in their particular scenario. It's a problem. It's a problem that, in one environment, a behavioral economist will say, "Oh, inequity aversion, that's the model, that's what we should use." And then tomorrow, in a different environment, the person says, "Oh, it's reciprocity." People shouldn't be doing it based on convenience. I think there's an effort in the field to, when you're thinking about a particular set of preferences, try to develop a model that you can just apply generally, that works in as many scenarios as possible. So you're not switching models based on convenience, but you've got one model, like prospect theory, that you'll apply to all choice under uncertainty. That's a desirable kind of model to use, and we're trying to do that, and we kind of give each other a hard time if we're flipping between models based on what's convenient. So I think the field is getting more responsible about committing to something. Yeah, I guess so.
Thank you.
Yeah. Yep.
How do they determine the numbers for the coefficients? Is it like a scatter plot and fit the line?
You can use choice data, so you kind of have to assume a functional form, and then you can use the choices to make a point prediction for each person's alpha, for example. or in a different model, a different parameter. So you get a distribution of alphas. And then you have like an average alpha, and there's variance for that distribution. So you can talk about how much people vary in the population. And they vary a lot, in this type of framework. Alphas really stretch the whole spectrum. But yeah, you can get one alpha for each person. Yeah. I didn't talk about that at all, but there are a lot of papers where, they've got the model in mind and they want to estimate the parameters. So they have people play different games, they gather all the choice data, use the choice data to estimate the distributions of parameters for their population. Yeah. That's a fun task.
Is there one question, sir?
Well, I'm around. I mean, my office is right down the hall.
Thank you.
Thank you
Thank
very
you
much.
very much. Thank you. Thank you. It was great to share all this with you today.
Thank you, very interesting.
So how do you think we can incorporate these kind of theories into system dynamics models?
Okay, thank you.
Do you think any
I mean, if you
a
tell me,
space for that?
how do you incorporate utility function system?
Let's go. That's what we're just looking at.
I've kind of answered to that question, but I just wanted to know your opinion. I'm working on this issue actually. I'm trying to incorporate these behavioral theories into system dynamics model, and so far I have
I think
got
it
some
happens-
interesting behavior.
It happens all the time. For example, there's a certain goal you're trying to meet, and that goal probably has been, the meeting that goal represents some sort of utility. And then you have decision rules which maximize that utility. Say, in terms of PID control, you meet that goal quickly without oscillation. So it's there in a way that you do not make direct measurements. That's what I think. You do not make measurements of utility. Instead, you try to meet certain goals which are clearer. So the modeling process maybe does not make direct use of measurement of utility.
Yeah.
So wait a second, but where's the question? Like if you figure out a way to include utility function, so reciprocity, like aversion to equity and all that stuff is just different utility functions. So plug it in. If you're comfortable about the way you include utility. Am I simplifying it too much?
Actual system analysis use different utility functions based. They don't refer to that. Actually, they don't say that this is our utility function or that is our utility functions. They just have some equations. I would say arbitrarily, but I think what is important here is that how people perceive utility and incorporate that information into making decisions in their system. And that's where I think behavioral economics has some important things to say.
Like we use the graphical functions all the time.
Right.
Yeah, but I didn't want to reveal this, but because it is not confirmed yet. I'm experimenting with a model, but can I have?
Marker. Yeah.
So I'm testing. So in system dynamics model, we usually have, for example, result of something. For example, income. So people work hard, for example, and gain income. Income generates some kind of utility, not directly but indirectly, from consumption, for example. In system dynamics models, we use a smoothing of that result over time, and all the time periods have the same kind of weight. So, but we have a peak end value theory, which says, and this is a behavioral economics theory, which says that people do not perceive their utility as it is, as it actually is. They just pick the end value of, suppose that this is the utility that that the person has gained over time. The person picks the maximum kind of utility and the end value of that utility and makes an average of these 2 points. Am I correct?
Okay.
And that will be the utility that that person will act upon. So,
So smoothing actually does create an expectation process in equilibrium, which is equal to the input. But over the period of change, in fact, it has a shape, right?
Mhm.
It has a weighting system. So smooth is a weighted function of the input. Now, we do use different kinds of smooth. We use, say, first order smooth, second order smooth, or third order smooth. And the weighting system in these 3 types of smooths is different. You can select information which is in the middle if you use a third order smooth. You weight the information which is most recent, most heavily in the first order smooth. So, but depending on
but
the situation.
in practice, I haven't seen any kind of, but if people do this, there is no theoretical foundation for that. If people have done this in system economics, I haven't seen any paper,
Explicitly.
any model that has a different smoothing formulation or justify that use of those functions based on the grounded theory. What I'm saying is that I think we need to be, from now on, we need to be more precise in terms of formulation of the models. What we are, because I have tested this, and the result was very significantly different from this kind of a smoothing and the conventional kind of a smoothing. The ultimate result was very different.
That should be interesting. Yeah.
So I will reveal that
Next time.
next year.
When are you presenting?
I don't know. I just wanted to talk to you to pick a date. that
We'll
work-
pick a date.
that
We have
work
to pick a
better.
Next week. Yeah.
Well, we
Next
have to
week?
find-
Next week.
Oh,
I mean,
For us
for
to
the
meet and talk.
presentation.
No,
So let's talk about that later.
So there are 2 issues there. One is that the different kind of smoothing will generate different type of behavior. And that's not a surprise for any system dynamicist. A different weighting function will generate different types of behavior. And the second question is that smoothing, that weighting process, does it fit a particular situation? That's the empirical issue.
You're right, but that's
which,
what he's talking. So what he's saying is you shouldn't just put in any smoothing function or any goal function that you feel like. There should be some foundation, hopefully
Yeah.
based on some of their work, in order to define those. I mean, it's
That's
a more elaborate requirement.
Yeah, my
That's-
point is that
that's
this
what we're
marriage
talking
would be very beneficial, especially for system enough. I don't see any benefit for behavioral economics.
Well, no,
But
I can imagine that they would allow them to do some modeling.
yeah,
That
maybe
otherwise they
for
can't do.
experimentation, it opens some avenue for experimentation, especially using games. I don't know.
Mhm.
It's just I'm thinking alone.
yeah.
So, but I think system economics can use very much from this kind of theories. It is, as you said, system economics models are macro behavior based on microstructures, and this is microstructure, and this is the theory that is working. Anyway, I'm trying to do this in my dissertation.
That's what we're talking about.
Cool.
Go for it.
Yeah.
No, he is.
I'm gonna have to take off.
Oh, thank you very
Okay.
much for your time.
Thank you
Not
for-
before
was
we
great.
take the
Thanks for the
time to
meeting.
meet.
Thank you. Thank you
Thank
very
you.
much.
Can we have your slides or
Yeah,
kind
yeah,
of something?
so,